This lesson is on what's called mean absolute deviation, and that sometimes is abbreviated as MAD or MAD. So the mean absolute deviation of a data set is the average distance between each data value and the mean or the average of that data set. So how far each data value is away from the mean, and it's the average of that. Mean absolute deviation is a way to describe variation in a data set. So the greater the mean absolute deviation, the more variation there is in your data set. So this sounds really confusing, but I think when I show you how to calculate it, it'll make more sense to you. So let's do an example. So here we have a data set, and it's asking us to find the mean absolute deviation of the data set. So the first thing we want to do is find the mean of this data set. And remember, to find the mean, you add these together and divide by how many numbers there are. So in this data set, I'm going to add these together. And when I add those together, I get 75. And then we divide that by how many numbers there are. And there are 6 numbers in the data set, so I do 75 divided by 6. And when I do that, I get 12.5. So the mean or the average of this data set is 12.5. And so for the mean absolute deviation, I want to see how far are each of these numbers away from that, and what is the average of that distance that each number is away. Again, I know that sounds confusing, but let's just take it step by step. So the average or mean value is 12.5. So now let's see how far away are each of these from 12.5. So find the absolute value of the difference between each data value and the mean. So I just take each of the data values and see how far away they are from the mean. So I take the mean minus the first data value is 12. And so that gives me 0.5. So the first data value is 0.5 away from the mean. And I take the next value, 12.5 minus 10, and I get 2.5. So it's a little further away from the mean. And then I take 18, and I'm doing the larger number minus the smaller number. I didn't 18 minus 5. 18 minus 12.5. Again, sorry, I'm doing the larger value minus the smaller value because it's asking me for the absolute value. And that's a way to ensure that I always end up with a positive value. So 18 minus 12.5 is 5.5. So that one so far is the furthest away from the mean of the data. So that shows a lot of variation when you're far away from the mean. And then the next value is 15. So I'm going to do 15 minus 12.5. And it's 2.5 away from the mean. And then I have 12 minus 12.5. So that value, that point is 0.5 away from the mean, pretty close to the mean. And then I have 8. So again, I'm going to do 12.5 minus 8. And that gives me 3.5. No, sorry, 4. All right, so what I've found is how far away each value in my data set is away from the mean. And so the bigger the value, the further away that number is from the mean of the data set. So now the last step, the mean, the mean absolute deviation is the average of these numbers. So now I'm going to take those numbers and see on average how far away are my values from the mean. So I'm going to take the sum of all of these, take the sum of these differences here, and that sum comes out to, let's see, I think it was 16. And then I'm going to divide that by how many data values there are, which is 6. So I'm going to do 16 divided by 6. And when I do that, I get 2.6 repeating. And the instructions here say round to the nearest tenth if necessary. So we're going to round that to 2.7. That would be my mean absolute deviation, or my So on average, my values are 2.7 away from the mean. Again, the greater the mad absolute deviation, the greater this value is, the mean absolute deviation, sorry, the greater that is, the more variation there is in my data set. So let me just rehash what we did. We found the mean of the data set. So we added them, divide by how many numbers there are. Then we saw how far each value was away from that mean. And then we did the mean of those values. And that gave us the mean absolute deviation. All right, so hopefully that makes sense. If you just go step by step, mean absolute deviation is not very hard to calculate. All right, so if that was helpful, give it a like and a subscribe, and please feel free to leave me a comment. Until next time.